So we start to teach you how to design the network of deep learning. So we start from page 29. So to design the deep learning has 3 steps. Step 1, 2, 3. And I organize the function. Each step, I organize the function here. 1, 2, 3. So the first one, we call network structure. Actually, it's meaning we try to design the topology or try to design the network. What's topology? Topology meaning it's a graph, G-R-A-P-H. It's meaning how, like for example, here. Topology is meaning for each layer, how many nodes you want to have. So you need to design how many nodes and how many layers you want to have. That's called topology. Node, right? Graph, node, and connection. It's fully connection or use convolutional. You want to use connective or use convolutional for the connection. So 2 things for topology. One is the number of a cell and the same number of layers, and that's for node, and the other connection. But that is 1D. For 2D is here or here. 2D is meaning the same. How many layers you want to have? Like a VGG 16, you want to have 13 layers plus 3 neural network. That's topology. And also how many downsampling you want to have. And then how do you connect, include, like you have shortcut. You have a shortcut here. That's all say topology. So this kind of connection is called topology. So first one, we need to design the topology for the model. Any model, like Gaussian model, H-Hindermarkov model, deep learning model, we need to use a graph. We need to define. So, but they don't have a value. They have a what? After you do the connection, after you have suppose I have 3 Gaussian model. 1 Gaussian model has a mean and standard deviation, so 2 parameters. 3 Gaussian model, you have 2 plus 3, and so multiply 3, you have 6 parameters. However, you have a weighting. So each model has a mean, standard deviation, weighting. So I have 3. Original Gaussian model has only 2 parameters, right? Mean, standard deviation. You have 3 Gaussian models together. You have for each model, you include 1 more term called weighting. So you have 3 parameters. So 3 plus 3 plus 3. So all the model, Gaussian mixture model, have a 3 by 3, 9 unknown parameters. That's topology. So after you define the topology, meaning you also define the number of parameters, unknown parameters. So topology has no, for the parameter has no value. It's empty. It's called topology. Topology 一定义完 ，model 就定义完。model 定义完就参数个数都定义完了，但是没有值。因为还没 train 呢，还没认呢。好 ，second step is that okay, I have this model. I have a Gaussian model. I have a Gaussian mixture model. The second is I want to collect the data. So the second is how do you do the data collection? The important for learning. One important thing is big data. How do you collect the data? How many data is good enough? Okay, if data is not enough, how can you do? And for the data collection, so here, For a data collection, also, if it's a supervised learning, you want to do the labeling to be the ground truths. So we think about labeling for the how do you collect it, how do you label it, how do you do the ground truths. And because we have big data, so we will consider the mini batch size. You want to 10 batch, for each batch has 10 samples, 20 samples, or 2 samples. 2 is too small. The last one you need to think about what's the loss function you want to have. So you will find this is the topology. This is the input output. Input data, input mini batch, output you compare with the labeling. Input output into estimated based on the loss function. So step 2 is non-linear data collection for the input, for the output ground truth, for what kind of loss function you want to have. So that's second. The third one is learning using optimization method. So after you do learning, all the parameters has a value. So that's done. We are done. So 3 steps. The final steps. Right now, we use gradient descent to do the optimization to find the global minima. But remember, gradient descent is not the best method, but it's good enough. People still think about, based on the machine learning that I teach you, expected maximization. Can we apply expected maximization to instead of gradient descent? So people already think about use expected maximization to replace gradient descent, but not success yet. 还没成功，但还在想怎么改良这最佳化的方式，这样子。好，这3个步骤，那我们就 So in this lecture, I will teach you how can we, based on these 3 steps, we want to design, we want to train the network. Okay. So first step, we have include 5 information. The first one is how can we do convolution? Convolution for what? For feature extraction. What's the theory? What's the process for feature extraction based on convolution? The second one is the activation function. What kind of activation function you want to have? The loop or others. The second is right now when I talk about, think about this one in page 27, based on this one. Okay. Is that how do you do downsampling? You want to use the maximal polling, you use stride, and how many downsamples you want to have. And then you need to flatten before here flattens here. After you do the network, you want to put the network curve for classification. And then here we need to, from 2D, we need to do the flatten because this is an NLP, so flatten become 1D input. And the final, we want to normal because your output, suppose you digits, you have 0, 1, 2, 3, 4 until 9, you have 10 digits. And then the probability, the summation of all probability should be 1. So if you normalize, 你有10个种类输出嘛，你输出的种类的总和要变成1嘛。So you want to use this Somax. But what kind of situation uses sigmoid? Because it's only one input, one output or 2 output, you can use sigmoid or tangent edge. So this is a design for the first one, topology. Okay, we start talk about it here. So this one. So this is the basic network. So we have input image, and then we have several convolution, downsampling, and flatten, and this is for classification. So this part is for feature extraction, and left-hand part is for classification. And then you will think about your output will be sigmoid or tangent edge. Sigmoid is from 0 to 1. tangent h is from -1 to 1. It's for one class. One class means foreground, background, something like that. Or yes or no, face, non-face. If it's face, it's 1. Non-face is 0 for detection. Or if you have more than one class, we will use softmax. Okay. So first one, we'll talk about feature extraction because we want to extract the important features. Okay. So that's for convolution. So for the convolution, usually before downsampling, we can have several convolutions. We back to the same. Back to 27. There's a VGG16. So after 2 convolution, you have 1 downsampling. 2 convolution, 1 downsampling. 3 convolution, 1 downsampling. How do they decide how many convolution? It's based on you try. So 这个16 13加3这个不是这样就来了，它是试了不同组合，发现这个是最好的。这试过了，你不用，就你有直接用就不用再试了，这样子。回到这边 ，So before downsampling, you can use different, not only one. Usually one is not good enough. 2 or 3 for the convolution. For each convolution, before 3 years ago, 4 years ago, people use convolution and then activation function. What's the purpose for activation function? The convolution is trade the information, and then you project to the other space. This projection based on the activation function. Activation function can let you be easy to do a discrimination. What's the activation purpose? Activation function purpose has 2. One is a transfer to new space, like eigenspace, like new space, like the new space. The second thing is that activation new space. First of all, transfer to a new space， 这是第一个目的transfer 到新的 space， 这样子。第二个是 because you transfer to a new space, it will be easy to discriminate， 容易把它区分开来了，就是 activation function 的 purpose 这样子。But recent few years, people include batch normalization. Batch normalization is because if you do the deep network, you do back propagation. If there's deep enough, and then the value will become vanish. 就是说，你如果你的这个深，上不用很深，可能是 VGG19、VGG16，搞不好或是 ResNet。你这样 back propagation， 因为它是每次都是变成分数嘛，连到1，然后 gradient descent 一直微分到最后，这个值会变0，这个问题了。那怎么办？你只要用 batch normalization 把它 normalize 回来，介于0到1之间，这样子让它可以继续做微分动作。所以 right now each convolution will not, they will tell you we do convolution, but be careful. Each convolution probably include convolution, batch normalization, and the activation function. But they just say, okay, we do one convolution. Okay. But some paper, they switch the position. Most of paper talk about is this order: convolution, batch normalization, activation function. Some paper is a convolution behind, or they switch batch normalization, activation function. So they're different kind, but most of the case I see is this way. So after you several convolution, we start to do the downsampling. You either use maximum pooling, or we use stride. Stride 1 is shift to 1 pixel. Stride 2 is shift to 2 pixel. We talk about this one. Downsampling. We talk about downsampling later. So we talk about convolution. So in the LeNet 2 plus 3, I told you this is not 4. This is only 2 because this is a convolution. This is downsampling. They combine convolution in downstem to be only one layer. So it's one layer, two layer, and plus three network layer. Okay, so 2 plus 3. So here we talk about the convolution. So this filter, the filter parameters are designed by learning. We do edge detection, so-called edge detection. Those parameters are designed by rule, by people. But here, the extraction convolution, this is high pass because we have minus. In the other class, I teach a student about the filter. If the filter has minus, usually this is a high pass filter. If they don't have a minus, that's low pass filter. Okay, so high pass filter is try to extract those good features. Okay, so they learn. So suppose this first filter, this second filter. Okay, so each filter, suppose image size is 6 by 6. So we start to do the convolution one by one. So this is linear combination. So this parameter 1 or times 1 plus parameter 2 minus 1 times 2 is 0. Parameter 3 times 0. So this is here. So after the first convolution, we got this value 3. And then we shift 1 pixel, become here. And we do convolution and become minus 1. So we shift entire 1. So we create a new feature we call feature map. Map is image, but here we call map. So one filter will create one map. Two filter will create two maps. So if we compare with the original one, this one cell, this one, they do connection. All the connection has parameters that's filter. But in 1D, they create one cell. Okay, but in 2D, here we create a map, like here. For this one, we create 6 maps. 2D 6 map. 1D is cell. So for each map, we use one filter. So we told here totally we have 6 filters. 2D filter create 6 maps. 是这个意思啊。Okay. So here, so one filter, we do convolution by straight 1. We create one feature maps and one feature map. Second filter create second map. Okay. But in this is next page 40. You will think about is 2D to 2D, 2D filter to 2D image. 2D filter to 2D image create 2D map. But inside your code, actually they do 1D. This one you don't need to care about. This one they will do for you. So in your code, even this 2D, but in your code they do connection like this way. So the first one, the positions, the image position 1, 2, 3 pixel 1, 2, 3, 7, 8, 9, 13, 14, 15. So the connection will be this one. 就是说，在你的那个程式里面，它是让你用2D 想，因为1D 会乱掉，但它程式是用1D 方式来写，所以你发现它每次做这个 convolution， 它就连接相对应的1、2、3、7、8、9、13、14、15。When they shift to next pixel, they'll do the connection become this one. 所以它这个 shift， 它这里就 shift， 就产生一个 map， 就这个 map 这样子。这里 you don't need to worry about this one. The code already do for you. Okay, so this is convolution. Okay, and then we talk about padding. P-A-D-D-I-N-G. Padding. Padding is what? Before this one, This is 6 by 6, right? And we do convolutions only inside 6 by 6 by 6. So I do the other one. Oh, that's easy to see. So you see the yellow one. So because each filter, I do this one. Each filter, all the convolution result will assign to the center here. 你整个 convolution 最后结果会 assign. So 3 is here. So you'll find this will become original 6 by 6 after you do the convolution without padding. And then you will become, the result become 4 by 4. So you will lose information of boundary. 这个 boundary 的地方，你的资讯就没了，这是 padding. So if you don't care about information on the boundary, and then you don't need to do the padding. But if you care about information outside here, you need to do the padding. So padding is like this one. So if this padding, back to page 42. If we are doing the zero padding by only 1 pixel, so this meaning the original one is 6 by 6, and then you'll check your filter size. If your filter size like this one 3 by 3, that's meaning your radius of filter size is only 1. 就你如果3乘3的 filter， 那你上半径是1， and then you are padding 1 pixel. So after this one, so your center will be here. So after you do the scan line, do the convolution, your output will still be 6 by 6. So the padding size is depend on your filter radius. If this is 5 by 5, radius 半径 2 pixels, so your padding will be 2 pixels. The second one is okay, the padding outside, what kind of number we should give him? For convenience, we can give him 0. 为了方便，我们给他0呢，0就是黑色，黑色 is black color is 0. If you want to get a better result, you can get the average value of feature map or average value of image and to be your padding. 这个值是你可以决定要给它什么值啦。OK， 那通常0就好了啦，还好啦。好 ，and that's the equation to tell you what's the padding. 那这个you don't need to care about this one. Just you don't need to forget about this equation. I just provide to you have this equation. The padding, the size of padding is the same as the radius of the filter. That's it. 很简单，所以不用管那个式子。好，the second one, after we do the convolution, the second one we will do is activation function. So that's important for activation function. So what kind of activation function we will use, and what's the purpose for activation function? And I have one example. In the net, all the activation function, the net, as I remember, they use a sigmoid. But right now, don't use sigmoid because right now it is deep enough. This is not deep. The net is not deep. Only 2 plus 3. 2 is not deep. Deeper is 5. At least 5. They define. So AxNet is 5 by 3. They call AxNet is deep. VGG16 is 13 by 3. They call very deep. And after very deep, nobody talk about very, very, very deep. No, just call deep learning. Okay, back to here. So here, because it's deep enough, so sigmoid is no good. Because what? Because the space, this nonlinear mapping, finally is they will destroy the. 他们一直做 nonlinear mapping， 到 nonlinear mapping， 那最后会有点扭曲掉的，有 distorted the data. Okay, but before we talk about that one, we talk about sigmoid first. Okay, so remember, you see right now all the activation function you'll find is very similar to what? to the exponential term of Gaussian model, because exponential term of Gaussian model has this exponential. Gaussian model exponential， 所以 Gaussian model 本身也有做一些这些 activation function 哦，不要小看 Gaussian model。好 ，So back to here. So what's the purpose for activation functions? Because right now, after you do combination, your output is suppose is 4, right? So the z is 4. But with activation function, I told you have two purposes. One is transfer to the new domain, new space. The second is try to normalize, become 0 and 1. And you normalize, so the input is this one. The output is y-axis. And we don't want, because finally we want to have a discrimination, classification. We want to have a threshold. So we don't want the value always around 0.5. It's not good. Because our purpose is try to do classification. We want our output value is either close to 1, suppose it's phase, or close to the 0 is non-phase. We don't want our output value between 0.5. So we do exponential term to push the output value to either 1 or 0. So this one. So that's why we use activation function. Okay. So this is different output that we continue. Okay. Actually, we talked about this one before, so we keep talking about. So this is one layer, second layer, third layer. Because it's deep enough, so people start thinking about, for each layer, should I continue to use sigmoid? And they find out, they'll do the test. They find out, oh, they don't need to, because sigmoid is cost time. 它会浪费时间 computational time. The second, because it's deep enough, so they don't need such complicated the nonlinear equation. So they use 连路 instead. 他们就用有点半线性的方式去逼近非线性，因为它已经够深了。那后面有个例子，再继续讲。So this is a sigmoid, but right now we don't do this way. This is the same. This is sigmoid, 就是 input 嘛 ，input。然后sorry， 这个是它的那个 input 这里，这个是前面的例子吧。This case is this case, and this case is this case. So final output is here, just that you know. Now this is parameters W, this input, right? And this is a bias, and this output here. This is just an equation that you know. So this one is for first layer. First layer input weighting is done, learning. So after you do learning, you do inference, you can put this weighting here. But when you do the learning, you don't have this kind of weighting. You also don't have the B. So W and B should get it from the learning. And this is a test. Tester will be output this one. Okay. So for the activation function, we talk about sigmoid, but right now, almost all the people don't use sigmoid except the final layer. Final layer is good for use sigmoid, but the between the input out and final layer, we almost right now we use rendu, liquid rendu, different kind of rendu. And then the other two famous is a switch and the mesh, both one. Both one, what's the good? Because our work, we use a gradient descent. Gradient descent has a derivative 微分 gradient descent 是依靠微分来做。那 derivative 你 smooth, 你 continue. So here is not good. This is not good. This is not continue.这不是一个 continue 的动作，这是一个 if 就是大于什么就是什么 if else 的动作。 所以这有个缺点，因为它不是 continue， 那微分会有问题。So some people, because this is not continue, so they use switch or mesh. So that's more continue, smooth, more smooth. So this switch and the mesh is more smooth, and they got the better result instead of renew. 它是 renew 的改良，它 renew 改良，那它为了针对 gradient descent， 它直接变成 continue。那我实验室我们目前做是有用到这个，但是还是有用到 renew， 也用到 liquid renew 的哈，大家让你了解一下。那这个我就没有，我们没有用到，但是这个 renew 6这个有用哦，这个是到 cut off。When they bigger than 6， 把它 cut 掉，这个有用。好，这是在那个MobileNet 会用到 ，MobileNet 会用到 ，MobileNet 是一个很好的 network。好，那这 explain to you what's switch and mesh because it's grade one is continue， 这有 continue 这样，这是让你知道就好了。Okay, and then I do one example of why we need to use activation function, and we can use renew. We don't use complicated activation function, and this is one good example for you. So we have input W1, W2, input X1, X2. We try to learn W1, W2, and B is bias. So we want to learn W1, W2, and B, and this output Z. This is linear, and after activation function become A is nonlinear. So right now, A is nonlinear output. So that's what right now we want to tell you is for suppose input this one, X1, X2. Okay, so output is like this one. Oh, sorry, right? Output is like this one. So you'll find this blue one and red one, right? You have blue one, you have red one, and this is input. So input is X1, X2 domain. So I say again, your input is this one. Your output is because it's exclusive or, so your output is the same will be no. Difference will be yes. So your output, the no will be blue color. The yes will be red color. So blue but how do you distinguish? It means you separate, classify. To red is one class, the blue is the other class, and your input sample is mean in the dimension 1 point we call sample. In the dimension x1, x2, we have 4 points. This 4 combination, 4 points, and then your output is either blue or red. And our purpose is try to distinguish the red will be one group, the blue will be the other group. So how can you do grouping for the output? It's impossible. So what can we do? So what's the purpose for the activation function is here. Okay. So the input here, right? After the first filter, your output will be A1. So what's the meaning for the A1? A1 is meaning the output is one dimension for the output. The second filter will output A2. What's the A2? A2 is the second dimension here. So in the 1D, each output, all of your input, each output is one dimension. So if you have 2 output after 2 filters, you have 2 dimensions. But for the 2D feature map, you will output this one filter, output one feature map. This feature map will be this one in one direction. In one direction, have one feature map. In the second direction, has second feature map. Okay. So right now, if we have a 2 filter, include 2 convolution, 2 filter, extract the information. Each one has one activation function to do the space transform. So after A1, So you will find, suppose we have one activation function. So original input 0, 0, 0, 1, 1, 0, 1, 1, the input. After you do the activation function A1 will become this blue one, 0.27 or 0.05 and 0.005 or 0.73 is way one。你本来是有这4个点，有4个输入嘛？经过你的 activation function 设计完转换以后，你会发现这是很简单的连入的东西哈。你会发现，哎，我的 A1 值就变0.27嘛，这2个值都变0.27，这2个值假设就变成一个0.73，一个0.25。This for one activation function to produce A1. The second activation function will be A2 here, and A2 will be the green one. So after from the original X1, X2 domain, you transfer to A1, A2 domain, your distribution becomes this one. So from here, actually, you can classify two different classes. One is yes, one is no. 所以经过这2个 domain， 你就可以把它区分出来了。这张纸，你原来4个点嘛，4个点。那经过这个简单的 activation function， 你就折过来了，对不对？所以变成这里2个红点，那这里变成重叠在一起。你这样就可以用一个线性的简单的线性方程式，就把这2个区分成 yes 跟 no 嘛。所以 here the purpose tell you why we need to activate. The first one, why we need to do activation function, because we want to transfer from original space to the beta space. And you can think about the PCA. PCA is good, eigenspace is good. So from original space, we based on the PCA, we transfer to the new space, eigenspace. So probably eigen 1, eigen 2, the same thing. 这是第一个重要的。第二个，你原来是 X1, X2 在这个空间嘛？那 if you have a more convolution, more filter, more activation function, one filter correspond to one activation function become one axis 一个空间。那 if we have 8 here, so they will become 8 dimension， 变8个维度了。所以你会发现，我们又回到刚刚这边，你看这里，我本来是有3个 channel RGB, or if you have gray value, if you have gray value, OK, 灰阶值，那你就是只有一个 channel。那 here become because you have six filter based on each filter corresponding to one activation function. So this become 6 dimension. 你变成6个 dimension 了，6个 map， 一个 dimension 是一个 map 嘛，6个 dimension。那 here become 16 dimension. So that's meaning we back to the beginning. The supportive vector machine. We talk about supportive vector machine. Here. Right. Sorry, here. Right? Here. So the concept from supportive vector machine, we from lower dimension, we want to use nonlinear discrimination. The same as we project to the higher space. So the higher space meaning you have more cells, or more feature map. It's meaning you have more high space, and then it will be easy to do the discrimination. So 我们会想要这要比较多层啊，我们本来是3层，就会变成16层、32层、64层、128，就是为了空间大。那这个好处是什么？ Because SVM you project to the 5 is a very high dimension, you cannot control dimension for the 5， 因为它直接投影到很高维度。 那 deep learning 不是这样 ，deep learning 是说 OK， 你每次只投高一个稍微高一点的纬度，那有需要的时候再投在稍微高一点纬度，再稍微高一点纬度这样子。所以那个投的纬度是你可以控制的，这样子。因为这 space 的 layer 是你可以控制的这样子。好，那我把这个讲完就下课。就回到这一边，说 activation function 在这里啊，在这里你就可以投影到比较稍微高的纬度 ，and then you can do discrimination。这是这个 activation function 的目的。我们再继续看，所以 see original this one after you do A1, so this is what A1 value. The second space, the second axis, the same space, second axis is this one. So we combine both to be one dimension, second dimension will become this distribution. 这样子。好，这是大概跟你讲这边就是一样。那你可以把它想成是 eigenspace 也可以了啊。那我们今天就先上到这里。那我们下礼拜继续讲那个 maxima pooling 这一个个重要的东西设计的结构。I will talk about next week. Continue talk about how do we design the topology, design the network. Okay. So thank you for today. So we talk about important thing, activation function, and we don't need complicated activation function. We just use simple like a redo, smidge, that kind of activation function. But we can have a more feature map, and we can have it become higher space. This is a concept. So we can easy for us to do that more deeper and more high. More deeper meaning we can have a more higher dimension, and it's easy for us to do the discrimination. OK， 那我们今天上到这边，谢谢。好，谢谢你们，辛苦了。辛苦了，辛苦你们，谢谢。好，那就这样哦，好，谢谢大家，谢谢大家。